Hello everyone. So today we are going to discuss backtracking, right? So yes, we'll be starting this backtracking in just 2 minutes. So we'll be starting this in just 2 minutes, right? So what does the backtracking actually mean? What it actually uh, does it, right? First thing is okay. Let us see how it works. A simple example, a real life example. Imagine, just imagine, I have wrote something like track this back. Now, track this back. So let me just move this over here. I think it will be visible now. I am clicking on this undo and then back. So undo, undo. So it is nothing but going in the reverse. It is just removing one uh, stroke again and again, right? So I am removing one and one, then redo, right? So I am just removing and then creating. So what does this actually mean? In this website, or this website name is excalidraw. So in this website, first it will be having something like he wrote T, and then he wrote R, and then he wrote A, and then he wrote C, and then K, something like that. Now we are just backtracking. That means our pointer will go here, and then here, and then here, and then here. Now if I do something like redo, that operation will take me here, then here, and then here, then here. So that's what a simple example of backtracking. But let us see how can we execute in real world problems. So let's open the first problem which we gonna do in this live session. Subsets, lead code problem number 78. So let me give you the problem number and also the name of the problem. Subsets. Okay. Okay. Right. Let us see. Given an integer array nums of unique elements, we are already given that the elements are unique. So nums array and given unique elements. Return all possible subsets, the power set. Let us see what does a subset actually mean. A subset of an array is a selection of elements, possibly none. We can also select no element also, right? The solution set must not contain duplicate subsets. Return the solution in any order. Okay, let us see. 1, 2, and 3. How can we actually solve this problem, right? Let us see. Can I get the subarrays? All the subarrays are present here. The subarrays with length 1 are present 1, 2, and then 3. So if you see 1, 2, and then 3. Now 1 and 2, yes, it is present. The subarray with size 2. 2, 3. Is it present? Yes. Now 1 and 3 is also present, right? So it is not just a subarray. Even if you take the subarrays, right? Even if you take subarrays, you're not getting 1 and 3. This is not a subarray, right? 1 and 3 is not a subarray. This is just a subset. So subarrays, taking subarrays with big O of n into n, nothing but giving two loops, a nested loop will not give us the answer. Now, how can we solve this actually? Is there any idea? Let me know in the chat box, right? Okay. Now we are having this 0, right? Okay. I think we can solve this in bit manipulation, but let us not go with the bit manipulation. We can just solve it using a recursion. 1, 2, 3. Okay. 1, 2 and 3, right? So we are given with nums is equal to, I am solving subsets. Lead code problem number 78. Nums is equal to 1, 2 and then 3. What is my approach to this problem is, let us start with an empty array. Let us start with an empty array. That's what I am talking about, empty array. Now, let us come to this index. Let us come to the first index, right, which is the 0, 1, 2, right, at index 0. I can take 1, or I will neglect taking 1 and I'll just take another values, right? If you see, there are subsets without 1. So we can take 1, or there is also a possibility that even it is okay that without taking 1 we can generate a subset, right? But let me tell you that subsets will be like here 3, right? The array size is 3. How many subsets did I get? 1, 2, 3, 4, 5, 6, 7, 8. This 8 is nothing but 2 power 3. So total number of subsets are, total subsets are 2 power n, where n is size of array. Okay. N is size of array. So totally we can get like 2 power n number of subsets. Now let us see. I said that I will take 1. Now the array is having only 1. Now I said that I won't take it. Now the array is empty. Now this happened at index 0. I'll do the same at index 1. I'll do the same at index 2 also. But let us see what if I go to index 3. You might say that yes, we go out of bounds and we'll be stopping there itself. Now, here if you see, I'm taking this one, right? The first element. Now, let us take the index 1. That's what it is here, right? So let us take index 1. At that point here, I am considering it and I am not considering it, right? There are two possibilities. I have wrote those two possibilities. I take this or I will not take this. I'll take this or I'll not take this, right? So there are two possibilities. I take this element or I will not take that element. Let us see what if I take that element. I'll get 1 comma 2. Now if I don't take that element, this element, if I don't take it, then the array will be the same one, right? No change. Now at index 1, I can take it or I may not take it, right? If I take the element 2, then the array will look like this. Now, if I don't take it, the array will be the same empty array. Now, let us see again. At index 2, I have this element 3. So, I will take 3 and write 1, 2, 3. This is the array I got. Now, I might not take it. I leave however it is. Now, I'll take it for 1, 1 comma 3, or I don't take it, then I'll get the same array. Now, I'll take 3 or I don't take the 3. I'll take 3 or I don't take the element. Now, if you see here, what are the elements or the summaries that I got till now? 1, 2, 3, 1, 2, 1, 3, 1, 2, 3, 2, 3, and an empty subset, right? Let us count how many I got. 1, 2, 3, 4, 5, 6, 7, 8. But you might ask me that we got 8 subsets. I'll stop there itself. No, will not stop like that. Will stop when the index is going out of bounds. If you see here, the index is 3. Do you have an element at index 3? No. So, if this index is greater than or equal to n, what is this n? N is nothing but the size of the array. So, if it is greater than or equal to nothing but if it is 3, then stop there itself. So, here it will return, here it will return, here it will return, here it will return, but this array will be included into our answer. Every array, nothing but the subset, will be included into the answer array, right? So what I am doing here, actually we are taking every subset and including that including every subset into another array. So we need int vector of vector int. Now, when I am stopping this, I am stopping when the index is greater than or equal to n. So let us write the base case, which is the heart of the backtracking and also recursion. So the base case is if index is greater than or equal to n, then return date itself. But if you see, returning itself is not enough. Return what you get by just returning. We need to include this array into the answer array. What is this answer array? What I am talking about is this vector of vector int, which is initialized as answer. So first thing, we'll be having the subsets or the arrays. Now, if the index is getting out of bounds, then take that array, push that back into the answer vector and then return. If you return before pushing the array into the answer array, you'll get a wrong answer. Why? Because you are not pushing the arrays or the subsets into the answer array. So wait a second, answer dot pushback. What name should we give to the array? Let us take the name as temp, right? So the base case is clear. Now, every time if you see, I'm taking or including the element and calling for the recursion or backtracking, or if not, I am not taking it. I'm taking here, I'm not taking it, and calling for the same function. So let us do one thing. Let us call for it. Let us call the recursion function or backtracking function. Let us name the function as recursion. Here, the index will be incremented, however. Why? Because we have started with 0 and then went to 1 and then 2, right? So, index will be incremented, however. But we do not include the current element, which is 2 here at index 1. Will not include and call for this function. So, let us not include any element into the temporary vector and call for it. Is there anything else? I think nothing, right? We haven't missed anything. So let us also include n. Now let us do one thing. Temp dot pushback. What's the current element? Nums of index. So I forgot one thing to mention is we also need to send nums array, right? So nums array need to be sent and also the size of the nums array. Now I have pushed back the element, this element. Now I need to call for recursion with that array. So recur index plus 1 comma temp comma nums comma n, right? Is there anything which I have missed? I think nothing. So this whole is the recursion function. Recur function. This is global declaration. Why? Because why I am declaring globally is because here we are pushing the temporary array into our answer. So that's why if we don't declare it globally, it might, the function will get confused. Where do you get the answer vector from? You are saying that answer, but I don't know what does this answer actually mean. Now, you might say that include the answer here after this, include or pass this answer in the function every time, but it takes like, this is just like a code. You can also do that, however, but I think this is a good way to write the code. It looks clear and clean, right? So you can also write, include the answer at the end of the function, pass the answer also, but let us go with the clean code, right? Okay, so we need to call this function, this recursion function, we need to call it. So in the main function, in the main function, what we'll do, we'll call for recursion with what is the index? 0. So when we are calling for 0, it will take or it will not take. First, it will not take and call for the recursion and then include the element at index 0 and then call for recursion. Okay, recursion index 0 and what is the temp is nothing but an empty array. So let us initialize vector of int temp, which is an empty array. So let us pass the temp array. Here I have nums array and what is n? N is nothing but nums dot size, right? Now I have called the recursion and it will call again and again and it will stop when index is greater than or equal to n. So at the last we can return our answer. So it might look like a big problem, but it is actually not. It is just an easy problem. However, let's see will it be executed or not without any errors. So let us do the code part. We have got the algorithm clear, right? So the base case and the recursion function, everything is clear. So only the code part is left. So let us do that. Let me open the, let me open this, right? Okay, let us, So if you have any doubts about backtracking or recursion, let me know in the chat box, right? Okay. So first thing, we need vector of vector int answer. So I said that we'll be initializing it globally. I think I didn't write it. So we'll be initializing this globally, right? Global declaration. Global declaration. Okay. Now this is the recursion function, right? Let us see. Okay. Now including every subset into another array. So we need vector of vector int. What is the name which I gave answer, right? Now here if you see, is there anything which I am returning in the recursion function? So no, nothing but a void, nothing but when we are returning nothing in the function, that means there is no return type. So we'll use void when we are initializing the function. So void recur, what are the things which we are taking? This is index and then array and then vector of int. This is the temporary array and this is the nums array and then size of nums. So first int index and then uh, vector of int temp. So I need to pass by reference. So then vector of int nums and then int n first. If index is greater than or equal to n, will return. But before returning, I need to push the temporary array back into the answer, right? Now a recursion of index plus 1 temp comma nums comma n, and do the same thing, but temp dot push back uh, what do you say, nums of index, right? Is there anything that did I miss? No, nothing. Okay, in the main function, vector of int, which is a temporary array and also an empty array, first recursion start with 0 and then temporary array and nums dot size, right? Return answer it there. Let me run the code. I think it works. No, it didn't work. So if you see, there are some cases which are repeating again. So if you see, I'm not removing the one which I have pushed back. So let me remove temp dot pop back. So if you have any doubts, please let me know in the chat box. Why is it giving, it has given me the wrong answer? Because here, if you see, it will go, for empty and then 1. Now if I don't remove it, but when it comes here, it will go to empty and then 2, and then here empty and then 3, right? I have pushed back. Then when it returns here, this will not be our temp, it will be 3, and when it returns it will be 3, and when it comes here it will be 3 comma 2. So it is a wrong approach of the problem, right? So if I don't remove the element from the temporary array, it will come with 3 comma 2, and then it will go here 3 comma 2 and then 3 comma 2 comma 3. Then this 3 comma 2 comma 3 will go here and then here and then here. Here it will come with 3 comma 2 comma 3 comma 1. So this is just a what do you say, a blunder which we need to look back, right? So we need to remove the element which has pushed back into the temporary array. Let me submit the code and check whether do I have any TLE or MLE, something like that. So yes, time taking 49 minutes. Okay, I have uh, opened this before before starting this session. Okay, so if you have any doubts, please let me know in the chat box. Right, we have started this session at 5:15 p.m. Right, it took us 25 minutes to go through this problem. Is there anything which we can solve? Yes, there is a thing, right? The constants are very low. The nums dot length can be still 10. We can use bit manipulation here, bit masking actually. Can anyone let me know in the chat box how can we solve this in bit manipulation, using bit manipulation? Let me know your approach. I think we can solve this in bit manipulation. That's what I am thinking, right? I think we can solve the problem with bit manipulation, right? Can we solve this problem using bit manipulation, right? I want to know, whether how many of you know about the bit manipulation, and this is something like a better approach, and it will take something like a less time, right? So can we solve this problem using bit manipulation? That's what my question is, right? If anyone know about the bit manipulation and how can we solve this using bit manipulation, let me know in the chat box. Yes, let me know in the chat box if you have any doubts and if you can approach this problem using bit manipulation. Yeah, let's also discuss about this bit manipulation, right? We'll also discuss about it, right? Okay, let us see how can we solve this using bit manipulation without wasting our time. First thing, what about the you know I said if we have the size as 3, n is equal to 3, I said there will be 2 power 3 subsets, right? 2 power 3 subsets. Okay. Now I said 2 power 3 subsets. What are those subsets, right? 2 power 3 is nothing but 8. Now, I'm saying that 8, there are 8 subsets. How can you represent this 8? I can represent this 8 by, okay, there will be 2 power 3 8. Okay, let us see. How can we represent this 8? 8, 4, 2, 1. Now, how can you represent 7? 1, 1, 1, 1, 2, 4, 7. How can you represent 6 actually? 4 and 2, 4 and 2, then 0. 5, 4 and then 1. 4, 1, 0, 0. About 3, what about 3? 2 and 1, right? So 0, 1, 1. Or about 2, 0, 1, 0. About 1, 0, 0, 1. So 1, 2, 3, 4, 5, 6, 7, 8. When I got 8, if you see all the places here, I got all these are different actually. All of them are different, right? At the same position, you don't get it again, right? You don't get the same pattern of 0, 0, 1. Do you see 0, 0, 1 again? No, if you see the 0, 0, 1 again, then you will see only when it is 9. So we are going only till 8. So till here, we don't see the same pattern. Can we use this pattern to initialize the arrays? Right? I am writing it in reverse order: 1, 2, and then 3. So how can you actually write this 0, 0, 1? So when it is 0, I'll take that element. If it is 0, I don't take that. So here, how many ones are there? Only one time. So the subarray is itself. No, okay. Now here, how many ones are there? Only one time. Where it is? At index 1, right? So let's take that element. Now here I got 2 times, 1 for 2 times. So 1 and 2, these are the elements in the subset. Okay, now I got a 1 for only one time. Where I got it? At element 3. So let me take that subset. 1 and then 3 at the elements 1 and 3. So let me take that 2. 1 comma 3. Now 2 times I got 1 for 2 times, 2 and 3. Okay, 2 comma 3 is a subset. 1, 2 and 3, I got every element. So 1 comma 2 comma 3. Now when I go to 8, you might ask me, bro, you have 3 zeros. Do you take any element? Absolutely not. Yes, that's why we got an empty subset. How many subsets do you got here? 1, 2, 3, 4, 5, 6, 7, 8. Absolutely correct way to go through the bit manipulation in this way. What I just did is, if you see here, if you see here, first thing, let us see how can you the second thing which we need to get in the mind is how can you get 1 and then 0 and then 0 like this, right? So you need to get that, right? So one right shift for one time will give you 1. Am I right or wrong? Let's check. Right shift for one time will give you uh, let us see, let us not do like that, right? I think I am going in the correct order, right? Okay, yes. Right shift for one time. Is there, am I going in the right way or not? Let us see. But doing a right shift for one time, what it will give me? Okay, right, okay. Okay, let us see. Right, doing a right shift for, let us do the right shift for 0 times first. Let us do the right shift for 0 times. Then you will get the same 001. If you do right shift for 1 time, then you will get 00. If you do right shift on the same thing for 2 times, then you will get 0, right? Yes, you will get 0. So it is like a simple and also clear way that you will go from 0 to 2, nothing but less than n. Yes, less than n. Do the same operation on this element. What is this element? Let's go from I is equal to 1 till I is less than power of 2 comma n, right? Less than 8 will also include an empty array, however, but we will go from 1 till 7. Okay, so 001. Okay, we are taking the same element. What is this element? I. So for every element I, do go for less than n. I'll take that as j. Okay, so first I'm going from I is equal to 1 till I is less than power of 2 comma n. Am I right? N is nothing but 3, the size of nums array. For j is equal to 0 and j is less than n, nothing but 3, n is nothing but 3. So 0, 1 and then 2. So first, uh, first if you got an element, right? Okay, if you got it as 0, let us see. If you got it as 1, so if, what is the element here? I. 001 is nothing but I. So I right shift for 1 ampersand 1. If it is true, then what we need to do is include that element. So temporary dot pushback nums of j, right? So we need to initialize a temporary array here, vector of int temporary array, and that's it. Is there anything which we need to do? For how many times here? Not one, it will be like j. So I right shift for j times. Yes, I is nothing but our I values from 1, 2, 3, 4 till 7. So I right shift for how many times? 0 times, 1 time, 2 time, and so on, lesser than n. So I right shift for j ampersand 1. If it is equal to 1, the last element which you get is equal to 1, then temp dot pushback nums of j. Include that element into the temporary array. Now, after getting all these elements, there will be one subset formed. So answer dot pushback the temporary array. Now, after this, return the answer. But before, n size of array, size of nums, let's say that as nums, and vector of int answer. That's what I need to return, right? So let us take this. This is the algorithm for solving the subset problem with bit manipulation. We have just solved it, right? So many of the students who are in computer science might know what a subset and also what a bit manipulation is. If not, so for one we will initialize it as 001. For two we will initialize it as 010. For three we will initialize it as, you know, 2 and 1. So 0, 1, 1. What we are actually doing here, it represents 1, here it represents 2, here it represents 4. So 1, 2, 4, 4 twos are 8, 8 twos are 16, 16 twos are 32, 32 twos are 64, and so on till uh, some number to power 32, right? That's what integer range is. So let us implement this encode part, right? So let me, okay, okay, let's do one thing. Okay, yeah, okay, all right. First, int n is equal to nums dot size. Okay, is there anything sorry, vector of vector of int of answer for int I is equal to 1, I is less than power of 2 comma n. Sorry, we have forgotten to include empty array, so I'm just writing it as empty so that we don't forget when we are at that part. So I plus plus, and then initialize vector of int temp for int j is equal to 0, j is less than nj plus plus, and if I write shift for how many times? J times ampersand 1. If it is true, then temp dot push back nums of j. Right at the last answer dot push back temp and include answer dot push back an empty array, then return answer at the end. Let us see. Let us see, will it work or not? Yes, it worked. Let me submit the code and let us take a break for 2 or 3 minutes, right? Okay, if you have any doubts, let me know in the chat box. So okay, let's go with the next problem in today's live session. I think I'm audible and it's clear, right? Okay, I think it's clear from my side. Let us go with the next problem. We have successfully solved the first problem just now, right? So, subsets 2. Given an integer array nums that may contain duplicates. Okay. Given an integer array nums that may contain duplicates, return all possible subsets. The power set. The solution set must not contain duplicate subsets, right? Return the solution in any order. If you see, the only data structure which stores without duplicates is a set. Let us do one thing. Subsets 1, I think we just removed it. Subsets. Okay, we have that problem here, right? Okay, we just submitted the code. Let us see the submissions, the previous submission, the first one using backtracking. So let us just copy this and let us see how can we solve this subsets with duplicate. Okay, subsets with duplicate. Okay, we have duplicates, but we should not get a, you know, the set, the duplicate subsets. So let us see, I am just including set of vector int answer, but we don't return the answer, we'll return result. Now what is this result? Vector of vector int result is nothing but answer dot begin comma answer dot end. Is there anything which I did here? Nothing. With I just let us see this so that you don't get confused what I'm doing actually. So I took the same code actually and have actually uh, changed only one thing. Here it is not vector of vector int, it is set of int. Why? Because set does not store the duplicate values, so it will also not store the duplicate subsets. So here the nums dot length is also small, which is nothing but only till 10, right? So we are creating a result array, nothing but vector of vector int. So result with answer dot begin comma answer dot end and then return result. Okay, what is the problem number here? Let me know. Let us see. Subsets 2 is the problem number. Insert temp. Let me run it. So the error is I have given pushback here. Let me submit it. Okay, I got a wrong answer. Let us see what it is. 90 subsets 2, right? 90 subsets 2. I have pinned the message. Let us see why I am getting a wrong answer. So 144. I think I did the correct thing, right? So we should not get duplicates. Okay, 1 4. We are not including the correct, you know, 4 1 4 and then 4 4 and then 4 4 1. All are repeating again and again and again. Answer dot insert temp. Okay, temp and then nums. I have submitted the same code, but it is a blunder mistake, I think. Let us see. Let us go with the description and let me check what error am I getting here. So 44414, right? So here I am getting 414, but okay. If you see, the subsets here are sorted, right? All the subsets. 414 is not present. If you see, 414 is not present. It is not present actually. 144 is present. Now, 4441, it is not present like 4441. It is present like 1444. Yes, that's where we got a mistake. Here also we need, let me initialize it as set of int, and here insert, can we remove the last element from temp? I don't know, can we remove it? Uh, we could remove it or not, but let us see. So here it is set of int. Here, is there anything which I need to change? No, I think no, right? But how to remove the last element? How to remove the last element of a set from a set in C++? Let us see. Yes, got it. We need to remove like this. Let us see. My set dot arrays instead temp dot rbegin. Okay, let me use this test case and let us see whether do I have any wrong answer or any compile error. Yes, answer dot insert temp. Okay, it should also be set of int. Answer should also be set of int. Okay, is there anything? No, I think no. Let me run it. I think yeah. So here I am creating vector of vector directly without changing the set of int into a vector of int, right? I think you got it. Let me tell you, for auto it in answer nothing but set. So let me say it as set. Okay, so I got every set. What I'll do is vector of int current is nothing but st dot begin comma st dot end. Now I need a result, right? So I'll just initialize it here, and result dot push back current. That's it. Is there anything which I need to do? Yes. In set, I think I can't iterate in a set with using auto, right? Iterate in set in C++. Let us see. There are two primary methods. Okay. Iterate st is equal to okay. Let us take this. Let us run that first and let us not be underconfident, right? st dot begin comma st dot end. Let me run it. I think we cannot go with auto st temp dot as temp dot r begin. No. temp dot insert nums of index, right? I think there is an error here. Yes, there is an error here. That means temp dot erase temp dot r begin. And is there anything which I am giving, like it is just a deadly signal? What does it mean? If temp is not empty, then only do this. I think it's not the error like that. Okay, yes, it's the error. Okay, output is 1 comma 2 and then 2, but here we are missing 1 2 2 and then 2 and then 2 2, right? We have missed 3 subsets. Yes, right. Okay, no, we have missed 2 subsets, right? Okay, let us see. We cannot include duplicate subsets. We cannot take 2 comma 2. Yes, it is present, but I don't know why is it giving me a wrong answer. Okay, if you see, when we are taking the set of int, it is not taking the 1 comma 2 and then 2 again. So it is giving me 1 comma 2 again, right? So it is not including the 2 for the second time. That's where I am getting an error, right? Is there any other way that I can solve this problem, right? Let us see. Let us do one thing. We got every element in our answer array in this problem. Subsets 1, the first problem, right? What I'll do, I need to sort it, right? Okay, okay, let us do one thing. When we are pushing back into our answer, we will sort it and then push back into our answer. Let us do that, right? So let me take this and then paste it over here and just take this. Okay, every time when I am pushing back, so sort temp dot begin begin comma temp dot end. Okay, now answer dot pushback. If it is a wrong one, it will not push that back into our temp. So it will be set of int and we'll return on result. So vector of int result is nothing but answer dot begin comma answer dot end. So result. Okay, is there anything which I have missed? Row, I think recursion int index, vector of int temp, vector of int nums, and then int n if index is greater than or equal to n. Sort temp dot begin and temp comma. And why? Because we will sort the temporary uh, array so that we don't get the answer like this 4 comma 1. Instead we'll get 1 comma 4, and if you get the 4 comma 1 4 comma 1 with this one again, 4 comma 1 with this one again, so as it is already sorted, so we'll not get a wrong answer. Let me submit it. Answer dot pushback temp, it should be insert sort for the mistake. Again, this is the second time I have did the same mistake with the set. Okay, we got a wrong answer again. So here I got triple one, double four, got a double 1 4. Right? There won't be a possibility of double 1 4. If temp is not empty, then only let me do that. Let us run the code again. I got the same wrong answer. So we have sorted it. 1114. I don't know why we are getting 1114, 1144, 444. Right, sort temp dot begin index plus 1. Let us see. Right. Why I think there is an error of taking the same element again, right? I think there might be a error here, right? So the approach that I am taking is like contains duplicates. Okay, okay. Given an integer array nums that may contain duplicates, return all possible subsets. The solution set must not contain duplicate subsets. Return the solution in any order. Right, let us see. So the first thing set of int, vector of int answer, right? I think there is an error here, right? There might be a logical error. If index is greater than or equal to n, then we'll be returning. Okay. Answer dot insert temp and then return. Recur index plus one temp common nums. Let's do one thing. Let us include the nums and then call for uh, call for this. And then I think there is no need of removing the element again, right? So before including the element, we have including the element. That means we are excluding the element. Vector of int is a vector of int is a temporary array. A temporary array is nothing but an empty array when we started our recursion, right? So result is nothing but answer dot begin comma answer dot end. Let me submit it. I think no, I got the wrong answer again. I think I need to change something here. Okay, I got nums and then 1 2 2 and then, so I'm getting the twos for more than 2 times. If you see, let's do one thing, right? So if I have the numbers in this order, in if you see, in a sorted order, sort the nums array first. Nums dot begin, nums dot end, right? Now we will call for the array with the nums and then temp, and let us also include the end. Now let us not go with this set of int and all. Vector of int answer first, void of recursion index. I got the index, and then vector of int temporary array, and then vector of int nums, and then integer n. First thing, let us just go with removing the duplicates, right? Let me tell you. First thing is, first let us initialize answer dot push back answer dot push back temp, and then let us do one thing. First, if we have duplicates, let us not include the element again. So for int I is equal to index and I is less than n, and then I plus plus, let's go with if I is greater than index and nums of I is equal to nums of I minus 1, then will not, wait a second, will not include that element into, will not include that element into uh, the next element again. Nums of I is equal to nums of I minus 1, right? If you get the same element again, no need of including that element, right? I is greater than index. Okay, the wrong answer is like this. Now you got the same one again and again, but I don't know, like, so I think we should not right, we also need to include 1 4 4 4, right? 4 4 and then 4 4, right? Let us see. Nums of I is equal to nums of I minus 1. First, let us include that. However, push back nums of I, and then temp, let us call for recursion. We'll do the same thing, and that means removing the element again. So call for recursion with I plus 1, nothing but the next element, right? So that means we are including the element again. Okay, I plus 1 and then temporary array and then nums and then n. After the temp dot pop back, let us run this. Return answer. So if you see here, 1, 2 and then 2, right? So first I is equal to index. Let us just say that answer dot pushback temp. That means imagine you got 1, just 1 into the temporary array. Now I is equal to index, nothing but 0. Now I is greater than index, and nums of I is equal to nums of I minus 1. Is there any I, is it I greater than index? No. Now temp dot pushback nums of I and call for the recursion I plus 1 temp comma nums comma n. So this 1 and then 2 will be included, right? Temp dot pop back. So temp dot pushback nums of I is nothing but 0, right? We'll be calling with index 0 answer dot pushback temp. So first answer will contain the empty array. Then we are starting with 1 and that 1 will be pushed back when it is called, and then we'll remove that 1 and then the empty array, right? After pushing the 1, now we got the temp as only 1. Temp array is having only one element. Now I is greater than index. If you see, when this I is equal to index, right, is starting from index, it is 1. So index is 1. Now temp dot pushback, so temp dot pushback nums of I, nothing but will include that 2 and then we'll call for the recursion, right? No, we don't have any error in this. Why? Because we are including 1 and then 2 and then 1 2 2, right? It is just clear. Okay. uh, if nums of I is equal to nums of I minus 1, then we will not include. Why? Because if you see, taking the same element will give you the duplicate values in the subset. So if nums of I is equal to nums of I minus 1, we'll just skip that section, that I will not push that back into the subset. So we'll continue, right? Okay, I think it's clear for now, and if you have any doubts, please let me know in the comment section, right? I think it's clear for you. I think it's clear for you. Let me submit the code. Right. Yes. So we have successfully solved two problems. It's 6:30. I have started this at 5:15. Right. Okay. Now let's come up with this problem, combination sum. Let us see how can we solve this problem. Right. It is just like when I have started solving this recursion and backtracking, felt like uh, a harder one for me, right? So Given an array of distinct integers candidates and a target integer target, return a list of all unique combinations of candidates where the chosen numbers is sum to target. You may return the combination in any order. Okay. Okay, the same number may be chosen from candidates and unlimited number of times. The same number may be chosen from candidates unlimited number of times. Okay, right, it is not like the subset sum. I think we also have a subset sum problem. First, let us look at that subset sum equal to target. Let us see. Do we have target sum? No, I think it is not this one. No, it is not this problem. Which subset partition equal subset sum? I think it is. Okay, let us give an integer return true if we can partition the array into two subsets such that the sum of elements in both subsets is equal. Okay, let us subset sum equal to k. Okay. Let us do this partition subset sum. Wait, let us see. Okay, given an array of positive integers array and a value sum, determine if there is a subset of array with sum equal to given sum. Okay, we need to determine whether we have a subset whose sum is equal to given sum. Let us see. Right, subset sum problem in gigs for gigs. Sum problem. Okay. So 334, 4, 12, 5, 2. 334, 334, 4, 4, 12, 5, 2, 5, 2. Okay, this is the nums array given to us. I think it's array. The name is array. Let's also take this as array. And the sum is given, the target sum, which is 9. We need to determine whether we can get sum or not. So we need to return true or false. Let us see how can we solve this problem. We need to get the subsets, however. So take 3 or not, just empty. Now what is the sum here? Just 3. Now take 3 and also 34. Now what is the subset here? Just 3. Take 34. Now if you don't take it, it is an empty array. Take 3 comma 34 comma 4. We also maintain the sum. Don't We need to remember that we also store the sum also, right? 3 comma 4 and then just 3. 34 comma 4 and just 34, right? Now 4 and an empty array. 12, the next element is 12. So 334 comma 4 comma 334, sorry, 334 comma 4 comma 12, 3 comma 34 comma 4, 3 comma 34 comma 12, 3 comma 34, 3 comma 4 comma 12, 3 comma 4, 3 comma 12 and then 3, 34 comma 4 comma 12, 34 comma 4, 4, 34 comma 12, 34, 4 comma 12, 4, 12 and empty subarray. So 12 and empty subarray, 4 comma 12, like this. 34 comma 12 and empty subarray, sorry, 34 comma 4 comma 12, 34 comma 4, 3 comma 12, 3, 3 comma 4 comma 12, 3 comma 4, 3 comma 34 comma 12, 3 comma 34, 3 comma 34 comma 4 comma 12, 3 comma 4 34 comma 4, and then 5. We have 5, but I think it's a waste of time, but for you I can go for it. So 3 comma, I need to take 5, right? So the next element is 5. So 3 comma 34 comma 4 comma 12 comma 5, 3 comma 34 comma 4 comma 12, 3 comma 34 comma 4 comma 5, 3 comma 34 comma 4, 3 comma 34 comma 12 comma 5, 3 comma 34 comma 12, 3 comma 34 comma 5, 3 comma 34, 3 comma 4 comma 12 comma 5, 3 comma 4 comma 12, and then 3 comma 12 comma 5, 3 comma 12, and then 3 comma 5, and then 3, and then 34 comma 4 comma 12 comma 5, 34 comma 4 comma 12, right? 34 comma 4 and 5, 34 comma 4, 34 12, and then 5, 34 and then 12, 34 and 5, 34, 4 12 5, 4 12 5, and 4 12, 4 12 5, and 4 12, 4 5 5 and 4 12 5 and 12 5 and empty subarray. So this is going to be very large, right? And then include 2. Let us see. Let us just take this like this, right? So take this element, duplicate it, paste it over here, and let us include 2 everywhere. 2 everywhere. Let us include 2 everywhere. Okay, so here 2, here 2, and then here 2, then 2 here, and then 2 here, and then 2 here, and then 2 here, right? So here 2, and then 2 here, 2 here, 2, and then 2, 2, and then 2, and then 2, and then 2 here, and then 2 here, 2 here, 8, and then 10, okay, 2, and then 2, then 2, 2 here, and then 2 here, then 2 here, then 2 here, 2, then 2, and then these things will not give me, however, sum of 9. We are asked for 9. Let us see. So wherever I got 34, I'm just removing it. Just remove where I got this 34. So I got this 34, which is greater. So wherever I got 12, there also I'll just remove it. So I have removed it. Now I got 8. This sum is 8. This is 3, and then this is 5. And here it is 7 plus 3, it is 10, right? Wherever I got 34, I'll remove it, however. So 34, I'll remove it. So 34, and then okay. Wherever I got 12 also, I'll remove there. Now let us see. Here the sum, no. 12, I'll remove it. So if you see, there is this sum 4 and 5 given me 9, right? So this is how the backtracking is. This much is the tree, and also if it is like the constants are large, I think yes, it is like 200, it might give me a like 2 power n, right? The wait a second, 2 power n. What is 2 power 200 actually? Let us see. 2 power 200 2 power 10 is 1024. Like it is just 10 power 60. If you see 2 power 200 is extremely large. That's what they are saying. We cannot accept the code. This won't be accepted. Why? Because this is gonna be large. 10 power 60 is much large, right? It is saying me that 10 power 60 is much larger, right? Even 10 power 10 is larger, right? So it won't get accepted, but it will be accepting the three test cases. Let us do the code part for this without wasting our time. I'll write the bool recur function. Bool recur function. What I need, I'll just tell you what I need. First, if index is greater than or equal to n, then we need to stop there itself, return. But first, sum is equal to the target, right? We are given with sum. So let us say that this is C sum is equal to sum, then we'll return true. If not, we'll return false if index is greater than or equal to n. Now we'll include the element into the sum, or if not, we'll exclude it. Now, do we need a nums array or a temporary array here? No. So we need a current sum. First, recur ask for recursion. Let me just write it like this. Return recursion of what is the current sum. Let us increment the index first, index plus 1, and current sum plus nums of index, right? So the current sum plus nums of index, is there anything which I need to give nums, right? Or if this is true, return it. Or I think yes, recursion of index plus 1, current sum is there itself. I included it, I excluded it, so nums, right? So what I took here, index comma current sum comma nums, but most importantly I missed sum. That's what many, even I did the mistake. So sum here, and then also wait a second, include the sum here also. Include the sum here also. First, we'll call for recursion of index is 0, and what is the current sum? It is 0, and nums and the sum. We'll just return it. I think it's clear for you, right? Yes. Let us do the code part. This is the first time I am using Geeks for Geeks in my live sessions, right? So bool recursion int index int current sum int vector of int nums and then int sum. Now if index is greater than or equal to n, what is n? N is nothing but nums dot size. We need to specify it, right? Okay. Now return current sum is equal to sum, then only return true. If not, we'll return false. If not, return recursion of index plus 1 comma current sum plus index nums of index comma nums comma sum, or recursion of index plus 1 comma current sum and then nums comma sum, right? Then return recursion of what is the index 0, what is the current sum 0, and what are the nums itself, and the sum is sum. Let us run it. Return recur nums, sorry, It is not nums, it is array, but here I am calling it on as nums. However, it will be the same. If you change the name in the function, it doesn't. Uh, okay, custom test case. Let us also give custom input. Okay, let us give a custom input. Sorry, but for 200 is a bigger number. We cannot give the bigger number for it, right? So sum is equal to 30. Okay, custom input. Let us also give a custom input. Here we are giving the target of 30. Let us see. Is it yes, 1 2 3, and the sum is 6. 1 space 2 space 3, and the sum we are giving is 6. Let us compile and run the code. But if you submit it, it will give you it yearly. Why? Because it is 2 power n, nothing but 10 power 60, right? Please optimize your code and submit again. We can solve this by using DP or even memoization, but let us save this problem for dynamic programming when we solve or discuss about dynamic programming, right? Let us see. Partition equals subset sum. This is also a DP problem. If you this will be solving right when we get through the dynamic programming. Why? Because the nums dot length is 200. Even if you solve it, when you submit this problem by using the recursion or backtracking, it will give you a TLD as the same as the geeks for geeks problem, the before problem. Subset sum equals to target. So 2 power 200, nothing but why 2 power 200? Why? Because the constraints are saying that we can get the n length, the array length, to uh, 200. So we are how many subset will have for a array which is having 200 elements? As I said, 2 power n subsets will be having. So 2 power n is nothing but 2 power 200 is going to 10 power 60, which is quite large. So that's why we are not solving that problem right now. Now let us look at the combination sum, and here the constants are less. Candidates dot length is less than or equal to 30, right? If you see here, it is not the same as take or not take. We can take the same element again and again. That's not the case with this. The same number may be chosen from candidates an unlimited number of times. Two combinations are unique if the frequency of at least one of the chosen numbers is different. The test cases are generated such that the number of unique combinations that sum up to target is less than 150 combinations for the given input. So the combinations can be less than or equal to less than 150. Right? How can we solve this problem actually? How can we solve this? Right? Let us see. We will do the take or not take concept again, but let us see how can we solve this problem. We have 2 3 and then 6 7 2 3 5. So firstly, let us sort the given array. Sort candidates dot begin comma candidates dot end, right? After that we will call for the backtracking function or recursion function. But what we will do in the recursion function, we will be having this target, right? It is just the same as the subsets or subset sum problem, but we can take the same element again and again. How can we solve this actually? Right, if you see this combination sum problem, combination sum problem, right? The problem number, combination sum, the problem number is 39. Combination okay. So 2 3 6 and then 7, right? 2 3 6 and then 7. And what is the target? We are given with 7. So the candidates, let us just take it as nums. However, we don't care whether it is candidates or nums. First, let us take 2. If not, we'll just remove it. After taking 2, we can take again 2 comma 2, and we can include the number, right? Or we can exclude the number. Let us take the number 3, or we can exclude the number, include the number or exclude the number. But if you see, every time I can call for, first I am including the number, right? So I am including the number at index 0. So I can take call for this, right? I can call with only this 2, or I can call with 2 comma 2, or I can call with 2 comma 3, or I can call with 2 comma 6, or I can call with 2 comma 7, or I can call the recursion function even without taking the array element. Now I'm at 2. What is the index here? Here it is 0 and here it is 1. Now at index 1, if you see, I have the element 2 and I may not take the element, so it is excluded, including the element now. Now include the element 3, right? Include the element 3. But if you see, do I have to include only 3? Can, why I cannot include the element 2 again? I'll tell you how. So when I am starting with this, I'll start from 3 and then I'll include 3 and then I'll include 6 or I'll include 7. Now, you might ask me, why aren't you starting from here? Why? Because I have this 3. If I start again taking this 2, I got this right. I got this previously. Why you need to take 2 and 3 again? So starting from the index, I'll take it. So it is not with the elements, right? So I'll take the element. I'll take the element, right? The element where I am at, and where, if you see, at index 0, I was at index 0, and then I can include 3. So sorry, we can go with 2, or include 3 and then 6 and then 7, or we can exclude the element, right? I think that's the correct way to solve the problem. We can include 2, or we can include 3, or we can include 6 and then we can include 7, or we can just leave that. So this is at index 0, 1 2 and then 3. Let's see what happens there. So at index 1 we can include index the element at index 1, but I think we are missing the repeated elements, right? I think we are missing the repeated elements. I think so. That's a combination sum. We can take the same element again. Okay, right. We can include the element, or we can exclude the element, right? Okay, let us see. But is it excluding the element necessary? Right, we are excluding there itself. We are excluding 2 and going to 3 here itself. Now let's see 2. No. If you see here at index 1, I am starting at index 1, right? At index 1, and I have pushed the element at index 1 into the given array. Okay. Now 2 comma 6 and then 2 comma 7, here 3. Here at index 1, 3 comma 3 and then 3 comma 6 and then 3 comma 7. Now for this 6 comma 3, 6 comma 6, 6 comma 7, 7 comma 3, 7 comma 6, 7 comma 7. Okay, now let us go to 6, the element here. 2, 3 and 6, 2, 3 and 7, 2, 6 and then 6, 2, 6 and then 7, right? 2, 7 and 6, 2, 7 and 7, 3, 3, 6, 3, 6 and then 6, 3, 7, 6, 3, 7, 7. I think we didn't get the 2 again, right? That's what I'm thinking about. We got 3's and then 6, but we didn't get the 2. So when we are calling for an index with 0, first thing, if first thing is, do it meet our target, right? Okay, I think it's correct way of solving it, but but only if you started by including, we have included 2, right? So we can start with the same index again. Let me tell you how. Right, so we started with 2 here. We started with 2 at index 0. Okay, we started with index 0. Now I'll include starting from 2 and include the same number 2, and the index is also 0. That's what I am saying. The index here is also 0. It will also start from 0. Now we can include the next element 2 comma 3 and say the index as 0. We can include 2 comma 6 and index is equal to 0. We can include 7, index is 0, right? I think you got it. We are starting with 0 again and again, right? And then we will increment uh, the index for 3. We'll start from 3 again. Let me tell you how. First, we'll start with the recursion code. First, we'll start with the recursion code. Let me write the algorithm for you. First thing in the recursion part, first, what are we expecting from this? First, we need the nums array, but first the index and the remaining or current, or let us say that remaining sum, the sum which is remaining, right? And temporary array, we need to include the temporary array, right? No, is there anything nums? I think so. First, if remaining is less than 0, then return there itself. Why? Because we are going to the sum which is greater than the one which is required. Okay, if remaining is 0, else if we got the answer, that means we got the array which we are looking for. So answer dot push back the temporary array. Else what we will do, for I is equal to index and I is less than nums dot size. Let's take it as nums instead of candidates. So nums dot size and I plus this. First thing is temp dot push back the current element nums of I. The current element is nums of I, and then the next thing is calling for recursion of first thing. The index will be the same, right? The index will be the same. And what about the remain minus nums of I, right? And then what about temporary temp? Yes, temp, we have pushed back the nums of I. And then what about nums? The same thing again. No, temp dot pop back. That's how we got with the subsets, but here we have just included the same elements again, right, in the recursion function. Okay, now what we did, we have sorted the array, and after that we have initialized vector of int temp, which is a temporary empty vector, and then let us initialize globally the answer vector of vector int, which will be returning. So return answer, but we'll initialize the answer array at the first. So recur of the index, we are starting with 0, and the remaining sum is nothing but the given target. We haven't got the target yet. Now temporary array and then nums. So we'll declare globally here vector int answer. Let us do the code part for this. Okay, I think it's clear for you. I need to write it in a medium font instead of this bigger size. Okay, vector of vector int vector int answer. No, a recursion is nothing but a void function recursion of int index and then int remain and then temp. What is the temporary array? So vector int ampersand temp and then vector of int nums. That's it. Nums. Is there anything? No. If remain is less than 0, that means we are going even lesser, even greater sum. We are going to include the sum which is even greater. Else, if remain is equal to 0, we'll just push answer dot push back the temporary array. Else, for int I is equal to index and I is less than nums dot size and I plus plus temp dot push back nums of I, right? And then I recur index comma remain minus nums of I, and then temp and then nums temp dot pop back. That's it, right? Here, after sorting that vector of in temp which is an empty array, recur 0 comma target comma temp comma nums is nothing but candidates. Okay, return answer then. Okay, let me run the code. I got a wrong answer of 232322, right? Int temp and then the same I, right? Oh, index I is less than nums of nums dot size. Yes, remain is less than 0, will stop there itself. Sort candidates dot begin and candidates dot and vector of int temp. Is there anything that we are missing, right? Remain is nothing but the target and temp is okay. Everything is perfect. Uh, Perfect in this code. I is equal to index, right? So here I am starting with index instead of I. So when we are pushing back a number, nothing but nums of I, we need to start at that I instead of index. So that's where I got a wrong answer, right? So we'll start with I instead of index. Why? Because index is nothing but we are starting again from the front. Let me submit the code here, right? Yes, it got accepted. Okay, so I think it's clear for you the combination sum here. However, uh, we are using the, you know, all the subsets and even more than the subsets, right? 2 power n, it will be even more than 2 power n. So if you see the time, also the time complexity is also more. And about the memory, we are using the temporary array. However, excuse me, however, we are using the temporary array, so that's why we'll be getting the most memory limit, right? Okay, we can solve this by using dynamic programming, but let us save those in the topic when we go to the dynamic programming concept actually, right? Let me remove this. So we have successfully solved subsets problem. That's the first problem which we have solved. Combination sum problem, subset sum problem. First we have we have gone through subset problem first, subsets, and then the second problem is subset sum problem, and then we have solved combination sum problem, right? Okay. It is showing an excellent connection. However, okay. Yes. Now let us see the problem into the next problem, permutations. Like I think, okay, nums dot length is 6, and yes, the constants are low. However, let us see. Given an array nums of distinct integers, return all the possible permutations. You can return the answer in any order. So the permutations are nothing but all the permutations, but we can go with the next permutation. But let's solve this by using recursion. However, let us see. Right? Okay. First, 46. Problem number 46. Permutations. Okay. We are given with 1 comma 2 comma 3 is nothing but given nums array. So what are the different permutations which we can get? So totally we got 6 here. Let us see how much we can get. 1 2 3 and 2 3 1 and 3 1 2. Let us put 2 first and then 1 3, right? Let us put 3 first and then 2 1. Let us put 1 and then 3 2. So totally I got 6 permutations. I got 6 permutations totally, right? If you have any doubts, please let me know in the live chat, right? Now how can you get the element first and then the next element in the permutations, right? That's what the question is. So first thing, let us create right, let us see. We will write a recursion function, however, right? Firstly, let's see, let's write the algorithm, but before that, let us see how can we solve it. So first thing, what if I take the element? If you see, the elements here are having 3, right? Every subarray, sorry, every permutation is having element 3, number of elements 3. So whenever I got the elements 3, then I'll stop there itself. Now uh, if you see, I'll start at 2 and I can go from 1 and then 3. I think I'm thinking in that way, right? Okay. distinct integers. So we are given with distinct integers, no need to bother about that. So first, this is a easy problem if I have to tell you, right? So let us do one thing. Let us take 1 and include that into the temporary array, and let us go from 0 1 2 again. Then when I get to this 0, that means the element is already present, so I'll skip it. Then this element is not present, so I can include it. This 3 is not present, I can include it. After including 1 and 2, I'll include 3. Will I include again 1 and 2? No. When I include this 2, I will include 3 and then 1. I'll tell you how it works. First, we will initialize. Let's initialize globally declare our answer array. Let's write the void recursion function. First thing, if the temporary array size is equal to nums.size, then answer.pushback temp, that means this current permutation is valid, then return. Okay, now after that I will go from I is equal to 0 to I is less than n, nothing but nums.size, and I plus plus. If the current temporary array, if temp dot find nums of uh, I is nums of I is not equal to temp dot end. So that means that there is no need to include it again. So continue. That means we are not including it again. And here, after that, if it is not present, temp dot pushback the current element. What is the current element? Nums of I, and then remove it again. But in between these two, we need to call for the recursion function. I will call for the recursion function with what is the uh, you know what is the number which we are including in it, right? What is the number which we are removing in it? If you see, like, we have the temporary array and then nums. Then let's go with the temporary array and nums. Now, do I have to go with answer and then include it in the recursion function? No. So we'll be having the temporary array and nums. Here in the recursion code itself, we're having this, right? Okay. Okay, if this is present, we will return, right? Let's see whether it is needed, the return statement is needed or not. Let us see. Why? Because we can, no, I think it is necessary to include that return statement, right? Let us see. Let us do the code part and then let us decide whether it is needed or not. We'll call for recursion function with temporary array and nums. Now, what is the temporary array? It is a temporary, an empty array. So return answer, but we need to initialize vector of int answer. Now, void recur vector of int temporary array, which and vector of int nums. So if temp dot size is equal to nums dot size, then answer dot push back the temporary array and then return there itself. For int I is equal to 0, I is less than nums dot size and I plus plus. If temp dot find nums of I is not nums of I is not equal to temp dot end, that means it is present, the element is present, then continue. Temp dot push back the current element, which is nothing but a nums of I. Now recursion temp comma nums and then do the same thing, but sorry, we need to pop back. Let me run this. Temp dot find, no, I think this how can we how can element is present in num in array in vector in C plus plus. No, it is in find nums. Okay, auto it is equal to find nums dot begin nums dot end search value for. Okay, auto it is equal to find nums dot begin, sorry, temp dot begin, temp dot begin comma temp dot end comma nums of I. So if it, if this it is not is equal to, then found. Okay, so if it is not is equal to temp dot end, it didn't went to the end. Why? Because it is already present. So continue. Okay, let us run the code. So it got accepted. Let me submit the code, right? So I think it's clear for you. If you have any doubts, please let me know in the comment section, right? Okay, I think it's clear for you, right? Okay. word search, right? Okay. Mm, start. Yes. Let us discuss about the next problem, word search. Given an m by n grid of characters both and a string word, return true if word exists in the grid, right? If not, we'll be returning false. The word can be constructed from letters of sequentially adjacent cells, where adjacent cells are horizontally or vertically neighboring. The same letter can may uh, the same letter cell may not be used more than once. Okay. Now A B C C D E A B C C D E A B C C E D, right? Right. Okay. The word given is A B C C E D. Now let us look at this F. If you have this F, will you go for that F? Why? Because the first letter itself is saying that A. So why we should go to the letter which is not the first letter, right? So we'll be going and searching for the first letter, and then we will go and search for the next letters in consecutively, right? Let us see how can we solve this. So we are giving this a board. Okay, first thing, where the directions where we can go. Let us write down that first. The directions which can be, or the cells which can be visited uh, when we are at a, you know, the next uh, the next cell which we can visit, right? Okay. So what are the number of rows which we have? So the number of rows, first let us see an example. A B C E, A B C E, and S F C S, S F C S, and A D double E, and then E. So the word given is A B double C E D. The word given is A B double C E D, right? So first I'll start at this point, and here I got a match. Now I'll check the top. Can I go to the top? No. Can I go to the left? No. Can I go to the bottom? Yes, I can go. But here I got S, but here I got B. I need B, but I got S. So will I go there? No. Let us go to the right. I got B, and here also I need a B. Then for this B, can I go top? No. Can I go left? I can't go to the left. Why? Because we cannot use the same letter again and again. Even if it is an A here, we cannot go from here and then here. No, we cannot use the same letter again. We can use one letter for once. No, I cannot go left. Okay. Can I go bottom? I can. But here I got F, but here I need C. Instead, I got F. Can I go right? Yes. What is the letter there? C. What I need? C. No. The letter I need is, the next letter I need is C. Now, can I go top? No, it is out of bounds. Can I go left? No, it is already visited. Can I go right? It is E, but I need C. No, I cannot go to the right. Can I go to the bottom? Can I go to the bottom? C, it is having C. Yes, I can go to the bottom, and the next this will be pointing to E. Now I have this C. Can I go top? Because no, because it is already visited. Can I go left? Yes, but what it is present here? F. But what I need? E. So no need of going there. Can I go to S? The right? Yes, I can go to S, but I need E, but it is saying S. Can I go bottom? Yes. What is the letter there? E. So match and then move the pointer to D. Now, can I go to the top? No. Why? Because it is already visited. Can I go to the right? I can go, but it is E, but I need D. No, there is no need of going there. Can I go to the bottom? No. Why? Because it is out of bounds. Can I go to the left? Yes. I have a D and I have a D and it is out of the index. So what is this? This is nothing but the index where I am with the row and then the column, right? I am checking row plus one comma column. I am checking uh, top, right, bottom, and then left. R comma C. Now this is my R comma C. What is this? R minus 1 comma same column. R plus 1 comma same column. R the same row, column minus 1. The same row but column plus 1. So these are the four directions which I need to go. Okay. uh, okay, let us see. First thing, if the current character matches the index, then only we need to go forward. If not, we'll be stopping there itself. So the first thing which we'll be going with is, uh, let us write the algorithm for this. First, whether is it present or not. So we'll write the recursion code. We will be having the board and the word, right? So the number of rows is board dot size, and number of columns is equal to board of 0 dot size. Then visited. If a number is visited, we need to see here, this is already visited. At this point of time, this is already visited. So how can I know that it is already visited? If I maintain in something like that, in a data structure. So for that, I'll use unordered set of string visited. We can also use a pair or vector of int or a, a set here, but instead if we use this string, it will be much easier to find out. And let us write a DFS function inside this recursion. So in this DFS function, we'll start with int the row R and the column C and then int K, right? Now auto DFS, the same DFS function uh, is passed, right? And this is a boolean function, right? So if K is equal to word dot size, then return true. This is nothing but will be incremented every time we get a match of letter. Okay, so if K is equal to word dot size, return true. If R is less than 0, or R is less than or sorry, R is greater than or equal to rows, or C is less than 0, or C is greater than or equal to columns, or visited visited dot visited, let us convert it to the string. So visited dot count, converting the current row and column, row plus comma to string the column, to string the column. If it is true, then return false. Yes, return false there itself, right? Now visited dot insert to string the current row plus comma plus to string the current column. Now the result will be boolean result will be DFS of r plus 1 comma c comma k plus 1 comma DFS, or DFS of r minus 1 comma c comma k plus 1 comma DFS, or DFS of r comma c minus 1 comma k plus 1 comma DFS, or DFS of r comma c plus 1 comma k plus 1 comma DFS. I think it's clear for you, right? We are checking all the directions. So that's why I said r minus 1 comma c, r plus 1 comma c, r c minus 1, r c plus 1. So these are the four directions which are possible. Now visited dot arrays to string c plus, sorry, to string r plus comma to string c. It is in RC format, first R and then C, so return result at the end. But if you see, we are counting the number of, if you see, let us see how can we go with it, right? So first thing, let us initialize unordered map of character comma int so that we know the count. So count C and D for character C in given word, count of C plus plus. Now if if count of word of 0 is greater than count of word dot back, right, then reverse reverse word dot begin comma word dot end, right? So if the first letter is having much frequency than the letter which is at the back, then we are just reversing the word, right? Why? Why? Because if we are having right, A and then A like this, A for many times, and then we have a B, C, D like this. So by just changing it, we can just start from B and then A and then D and then C and then A and then D, C, A. But if you go from A, there might be a chance that you get A, something like this. You get an A here, but if you see here, you have A and then A, but what if at these points you got B here, B and then B? So going to A and then A is giving me like a wrong answer, or getting me to the wrong answer uh, in even after going to that. So A and then I went to A, but if I am starting with B, I go to A directly. So as B is lesser than A, the frequency of B is lesser than A, it is easy to go to B, right? Now imagine there are A's like this. Now every time if you are having these many A's in the word, I need to start here and then here and then here and then here. So I am starting for 4 times. But if the starting letter is B, then it is easy to start at this B, even if there are many B's in the matrix, but it is easy that we don't go to every A in the matrix. We can go to every B, but we stop there itself when we get the next element, a mismatch, right? So it is better to reverse the string if the first character is having much, you know, much frequency than the last character, right? Okay, now for int r is equal to 0 and r is less than rows, the same thing with for int c is equal to 0 and c is less than columns and c plus plus. If dfs of r comma c comma 0 comma dfs is true, right? If it is true, return true there itself. If not, will return false at the end. I think you got it. Let us write the code here. Right, bool exist. First thing, let us go step by step. Right, okay. First thing, int rows is equal to board dot size, columns is equal to board of 0 dot size. Is there anything which we forgot to mention? No. Unordered set string of visitor, right, auto dfs is equal to ampersand int r int column int k auto ampersand dfs. Then if k is equal to word dot size, then return true. If r is less than 0 or r is greater than or equal to rows, or c is lesser than 0 or c is greater than or equal to columns, or visited dot count to string r plus r to string column, sorry, rc, right? As we got it, then we will return false there itself. Now visited dot insert to string of r plus a comma plus to string of c. Now bool result is equal to dfs of r minus 1 comma c plus k comma k plus 1 k plus 1 comma dfs fs or dfs of r minus 1 comma c comma k plus 1 comma dfs fs or dfs of r comma c minus 1 comma k plus 1 comma dfs or dfs of r comma c plus 1 comma k plus 1 comma dfs, right? Now visited dot arrays to string r plus a comma plus to string c, return result at the end. Now after that, we'll be using unordered map of character comma int, unordered map of character comma int, and name it as count. Now for character c in word, count of c plus plus. If count of word of 0 is greater than count of word dot back, then reverse word dot begin word dot end. After this, for int r is equal to 0, r is less than or equal to r is less than rows, r plus plus. For int c is equal to 0, c is less than columns, c plus plus. Now we are calling for dfs, r comma c comma 0 comma dfs, return true, if not return false at the end. Let me run the code. Okay, visited, undeclared identifier visited. Okay, so here I gave a vis, but they're visited. Okay, let me run it. I think I made the same mistake. Okay, return visited. Okay, return result. I need to this is a function, right? A structural function, so I need to use the semicolon. No, int rows is equal to boards dot size, columns is equal to board of 0. Right, int rows is equal to board dot size. Right. Okay, right. I forgot to mention this bool. If k is equal to word dot size, return true. Let me run the code. No, it's not even that one. Auto dfs is equal to yes, int r bool. Yes, I forgot to mention the bool. If r is less than 0 or c is less than 0. Or both of rc is not is equal to word of k. Let me run it. No, it's not the same. It's not the mistake. Okay. Let me do this. Or the board of RC is not equal to word of K. Right, okay. We are right in this. Return false if r is less than 0 or r is greater than or equal to rows and c is less than 0, c is greater than or equal to columns, or visited dot count to string r plus to string c, or word of rc is not equal to word of k, then we'll return false. Okay, visited dot insert to string c. Now bool result is equal to fs of r minus 1, sorry, r minus 1 comma c here, but here r plus 1, r comma c minus 1, r comma c plus 1. Yes, I didn't visit a direction, so that's where I'm getting a wrong answer. So if you have any doubts till here about the regression and backtracking, please let me know in the in this session itself. All right, so yes, if you have any doubts, please let me know in the chat box. So we will be ending this session in 12 minutes.